This video will be a repeat of a problem done earlier by hand, but we're going to be doing affine matrices. An affine matrix lets you do calculations that you would have to do one at a time by hand, but as matrix multiplication. This top set here, that is for translation. So you'll see here's the translation matrix. This is for 3D, and this is how you do it. These are the translations x, y, and z, and then each part of a vector x, y, and z, and then you add them. And then this will translate the different points x, y, and z. This one down here is for dilation, x, y, and z, and then a 1. And this is how you do with your vectors x, y, and z, and it dilates each one of those. What I have here in yellow, that is the 2D version of it, which is what we're going to be using for this problem here. I have diagonals here so that you can see the center of the square. You don't need it, but it's nice to have. We're going to translate it to the origin. Then we're going to dilate it, and then we're going to move it back, all by matrix multiplication. Now you might be thinking, oh, I don't want to take the time to learn this new thing. It's actually very simple. Just run through it a couple times. You'll be very glad that you did. So first thing we're going to do, we're going to take all of these points here, and I'm going to put it in its own matrix. I'm going to start from the right there. So we've got 6, 3. You'll see why I'm doing this in a minute. 6, negative 5, negative 2, negative 5, negative 2, 3, and then the center point 2, negative 1. Again, you don't need the center point. I like to do it just so I can see where everything's going. And then the last thing on here, I'm going to append this matrix. So there's a 1, 1, 1, 1, and 1. You might be asking yourself, what do the ones do? That's just how the affine matrix works. So now, for a translation matrix in 2D, we've got 1, 1, 1, translation y, translation x. So 1, 1, negative 2, because we're going 1 up and negative 2. 1's on the diagonal, 0, 0, 0, 0. That will get us to here. I will be doing all these calculations on Desmos matrix. For now, we're just writing it out. That's going to get us to here. Now the next one is the dilation matrix. So in a dilation matrix for 2D, 1, dilation y, dilation x. 1, 3, 3. The rest are zeros. You don't have to understand exactly why this works to do it. You should work through it and do that. For right now, learn how to do it by doing it. Then we're going to take this translation matrix and make the opposite of tx and ty. So that's going to be 2, negative 1, 1, 1, and the rest are zeros. It's a little awkward by hand, but you'll see what we're doing in a minute. Make sure you write this down, and we're going to switch over to Desmos matrix calculator. And you will see here that the matrices are already put in. So here are my original points, the center 2, negative 1, negative 2, 3, negative 2, 5, and so on. So I'm going to right multiply by this first translation matrix, and that gets us to here. The center is 0, 0. The points on the square are negative 4, 4, negative 4, negative 4, and so on, getting us to here. Now that we translated it, we're going to dilate it, and you just do that by multiplying, left multiplying. Now by the dilation matrix C, our center is still 0, 0, and then we've got negative 12, 12, negative 12, negative 12, and so on around the circle. Now that we've dilated it, we're going to left multiply by D, and that gets us to here. So now we've moved our center over to 2, down to negative 1 from 0, 0, and you can see the rest of the points here. Negative 10, 11, negative 10, negative 13, 14, negative 13, and 14, 11. And again, this row of ones here is so that the affine matrix calculation works. Don't read anything to the row of ones here. So again, this is affine matrices. It allows you to do your translations as a matrix multiplication operation, and then do your dilation as a matrix multiplication, and then move it back as a matrix multiplication, which is very, very nice. Do this a couple times, get used to it. You will be very glad that you did.